Hey, so we just got done with this Codeforces round 823, and I'm pretty sad about it because I couldn't solve B because a lot of people couldn't solve B and I was just stuck at it. So I actually just ended up solving only A, and I just looked at the blog and just found out that they have posted this editorial. So I really wanted to talk about these approaches and yeah, this is just like a solution video for B. So if I teach someone this problem, I will understand it much better. So I'm gonna first go through the second approach and then maybe try and understand the first approach. So the second approach was it says that if there were no TI, so basically if so the question was goes like if there are n people on a Cartesian line and it takes like some amount of time to for them to get ready, so each of them has a different time to get ready and they have to meet at a single point. So what is the minimum time they can all reach it in? So that was the question. So so the solution goes as follows. uh, If all Ti were equal to 0, then it would be a classical problem where we would find the average and the minimum and the maximum coordinates of people. So this basically states that if there are two people, let's say, let's consider two people, then the optimal time or the optimal point where they will take the least amount of time will be the between two, right? Exactly half of it. If there is no time involved in getting ready. So if this guy, because it is assuming that people walk at same speed or something like that. So this guy will take the same time as this guy when it's in the middle. But the picture changes where this guy takes, let's say, ti seconds and this guy takes some tj seconds to get ready. Now the optimal position of this is not at the middle. It depends on ti. So if let's say ti is more than tj, so this guy takes a lot of time to get ready. So that means this point should be tilted towards this guy. So something like here, so that it compensates for the time he takes to get ready and the overall time is minimized. Yeah, so that's, but by how much? Question is that. So what should be this? Uh, let's see further. Now they say that we can replace every person with xi minus ti and xi plus ti. So let me give some intuition for that approach. They have given a proof that states that if we do that, it's always like one would be smaller than the other. Then the maximum two values of always be equal to the initial value. But that is a bad proof, I think. So let's say we want to minimize the time, right? So we want for only two people, we can calculate it using something like so that the time of this should be equal to this. So if the time required here is equal to the time here, then that would be the optimal time. And that can be seen by like an observation or something. So That means Ti plus Xi. So X is this, Xi is this, let's say. And let's say this is at zeroth position. And so this guy will take Ti plus Xi time, and this should be equal to Tj plus whatever his coordinates are. Uh, let's say Xj. So Xj minus X. Let's say. And for this we can do X minus Xi if we don't assume this to be zero. Say X minus Xi. So some kind of this thing will come up, and so X will come out to be, so 2X come out to be Tj minus Ti, Tj minus Ti, and plus Xi plus Xj. Right. So this will get divided by 2 when 2 comes out. So we clearly just get a classic formula. So that means if we can do that for 2, we can do that for 3 as well. But here, what will we equate? So I just got stuck at this situation. Now let's look at what they are following in this. So what they mean to say is that instead of putting x here, so let's say this is xi. So let's say x was here. So the meeting point is here. So for a point at xi location, the time taken would be equal to t I, that is the time he takes to get ready, plus the absolute value of xi minus x minus xi, right? For in this case, it would be larger. So let's just assume this is x. So what I mean to say is, if we include this in the time it, so let's just assume that he is actually at this position instead of being at xi, he is actually at xi plus xi minus ti, let's say xi minus ti. So when we assume this, we can now just say that it will take xi minus ti time for him to reach x minus xi minus t, which is the correct thing, right? So if we keep the make the meeting point come closer to this guy, the answer will automatically reduce by this amount. Now the only problem with this solution is, or this approach is, that the time will be same for this guy, but when we come closer to this guy, when we reach a point that is closer than ti for this guy, so this is ti, let's say, so going any further closer to this guy would result in no reduction of time. So what I mean by that is, because we assume that he is ti distance away from us, but in actually we can't change this ti, so we cannot go closer to him and reduce the total time. So we can't reduce more than ti. So, but for our general case that takes in the average and stuff like that, we will just adjust this accordingly to this, right? So to overcome that, or just to counteract that, we can assume a point at exactly, let's say, this was x minus t, we will assume a point at x plus ti. So this is my explanation for it. So when we assume a point x plus ti, this would actually nullify the thing that this thing does. So if we'll try and go closer to this guy, we will reduce the time for this guy. So the time for this guy, one guy, let's say one, and let's say two. So the time for one guy will reduce, but the time for second guy will increase. So this is basically counteracting for this guy, and that is how taking an average of these all elements by replacing each member with xi minus ti and xy plus ti makes sense. Yeah, so that was the second approach. According to me, they haven't explained it well though. What they have done is that they haven't talked about nullifying things or countering things. Like this will cancel the reduction in time by this. But they have told us about so like what do- they have said that this will result in two values, this and this, and the second one is not greater than initial value. So what they mean is that, yeah, they mean the same thing kind of. So when the, let's say, the distance from this guy will increase and this guy will decrease. So one will one will always be greater than the other, and so that won't make any difference. Kind of like this. But how would that not make any difference in average? That is what my explanation explains a little bit better, because exactly the amount that this will increase in the average, this will decrease in that average, or if this will decrease, then this will increase. So it will all make sense. So the second approach they have talked about is that, let's say this guy, let's consider time interval t. So in time t, this guy can reach which spots? So if the time taken by him to get ready is already greater than the time we give for each member to move, is like lesser than Ti, then this guy cannot move anywhere. So this guy will stay at this position. But if it's greater than this, then he can go on a segment, like go over this segment. And what would be the segment length? That would be T minus Ti. So T minus Ti here and T minus Ti here. So if he is at xi position, then he can go to the right here and left here. So what we can do is we can assume a t, a random, take a random t, and check if what will we check? Now that's the question. So now each person will be able to move that far, right? Depending on their ti, it's a tj. So the condition where they can all meet, so where they can meet will be when the left minimum left of this segment would be greater than or equal to the minimum, so the maximum right. This is what they say here, right? minimum right borders is greater than or equal to the maximum left border. Sorry, my bad. So what does that mean? That means, let's make sense of it now. So maximum left will be greater than or equal to the maximum of the left borders. Yeah, so these two will meet when these two will intersect, right? So this segment will intersect with this segment, right? So if I have another member here, so this guy would have something like maybe maybe like this segment because it depends on the TI, right? So the maximum of left would be equal to this guy because out of all the left, so no, maximum left would be this guy is greater than equal to the minimum of right. So out of all the rights, this, and this, the minimum of right is this. So this maximum left is greater than equal to minimum of right. Then they can all meet. But in this picture, we can clearly see they can't meet. Hmm. Minimum of right borders. This is the right border, this is the right border, and this is the right. And out of these, the minimum is this guy. So if this is okay, the minimum of right borders is greater than. So this should be greater than equal to the maximum left borders. Only then they will intersect. Yeah, so that makes sense because then everyone can reach anywhere, everyone else because there will be a point where everyone will intersect, right? Now that makes sense. Yeah, so that is basically the solution of first. I kind of understood it along the way. Uh, by asymptotics, they mean the time complexity. So the time complexity is n log n because we'll have to binary search. So the reason we can use a binary search here is because the condition where it satisfies. So the variable goes like this. So if we choose a sufficiently large t, right? So if we choose a sufficiently large t, then all of these will satisfy, right? So if this is a function, if it's satisfied or not, and it is like this 1 and 0. So all of the t's that are greater than this exact t will satisfy, right? Because if we give more time to people, then they can travel more further outwards. So for all t greater than some t, we'll be able to like uh, intersect or everyone or basically reach at a point inside of that t. So the function looks like this, and if we go smaller than that t, we can't. So whenever we have a function like this, we can use binary search to find this thing. And when we have found out the time, we can quickly find the point where we have to place the x. So the implementation looks like these. So the binary search implementation is this. Let's understand this together. I haven't read it. is the input. They are multiplying each xi by 2. I don't know why they done that. Why would they do that? Okay, they're multiplying ti by 2 also. Let's see why they have done that. So the left is negative 1 and right is infinity. Does that make sense? So what are they considering L and R to be? So while R minus L is greater than 1, that is weird, but okay. So MXL and MNR, two variables, I don't know why have they taken this. So they go through a loop, and if the Ti for I is greater than M, MXL is infinity, MNR is 0. What do they mean by M here? M is this. I kind of don't understand this. So basically, this means that if the time taken by this guy is greater than the time we allot them, so this denotes the time exactly. So if that is the case, we just replace MXL with infinity, MNR with 0 by maximum L and maximum R. And we else, if it's not the case, then we take the maximum of MXL and XI minus the time we allotted. Yeah, so this is the segment where we can reach. Yeah, so basically this denotes the maximum left and this denotes the minimum right. And whenever maximum left is less than equal to minimum of right, we say R is equals to M. So yeah, so we put right equal to M. So we basically put right equal to M. So we try and find a better solution, but we still have a solution there, right? Maximum left is less than minimum of right. So we have a solution here, but we are trying to optimize it more if we can. Else we just put L equals to M. Here we did not find a solution, but we know that it's on the right hand side. So first let's say we went here. So for this guy, this wasn't the case. So we made this to be the L and this to be the R. So the mid is somewhere here. So now we have reached a point where this satisfies the condition, but we want to do better. So we put R here. So we try and do this, and eventually we reach this position. I don't know why have they done this though. So when we come out of the loop, that happens when this case happens. So when the difference between L and R is none, not great, is greater than, sorry, lesser than 1. So the fuck have they done here? So they go over each and every element. So R had the result, right? So they do this and they see out the maximum left by 2. Why? Uh, 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 uh. If maximum left by 2 is not divisible by 2, then they just add a 0.5 to it. Why do they do that? We don't know. Okay, so they just take the maximum lefts, right? As per the variable name, I'm just assuming. Yeah, so they do take the max and left of all of the segments. So that is like left of this, left of this, left of this, some segments, right, left of this, and they take, and then what do they do? They just do max L divide by 2. What? Why do they divide by 2? I don't get it. So we just found where, let's say, these are the two people. So these guys intersect at R. So they're like this. So the maximum left of this, maximum left is this. So why would they divide by 2 this guy? But instead they should do a minimum, right? Oh, sorry, maximum left is this guy only. So no. That's not maximum left. That's min, right? Oh, so the maximum left is this guy actually. So they take this and they divide by 2. Why do they divide by 2 though? Like for these two conditions, let's say 1 and 2, this would actually mean exactly at the mxl, right? Shouldn't it be? Hmm. Why do they divide by 2? So if a guy can go up to the max of left, how will we reach mxl by 2? That doesn't make any sense. Oh, they multiplied it by 2 at the start. Fucking amazing. It all comes a full circle now. So thanks for listening to my bullshit. Let's see the code for this one also. They also multiply by 2 here. Oh, so this is the same code. My bad. So they just add ti and subtract ti, and they just find the min and maximum. They sum the minimum and maximum and just display sum divided by 2. So for these guys, for the first part, they just take the average, but in a weird way. So they kind of don't consider each and every value. They just consider the minimum and the maximum. Let's take the average of these. Weird. But kind of like these are the only things that matter, right? If you take the mid of these, then these one would anyways be smaller than these, the time taken by others. Right. It makes sense now. Kind of makes sense. Yeah, so that was something. Yeah, if you enjoyed it, And sometimes I even don't know how to explain stuff, but making videos like this, like teaching stuff like this, uh, helps me understand the answers a little bit more. Like some things I didn't understand, but kind of like with teaching, I realize like at this point I'm lacking, or this thing I was not clear of. Like I'm still not clear why a difference of one was necessary. Kind of something to do with two. Like just tell me in the comments why is it, why are they multiplying by two and stuff like that. So I thought they were multiplying by two for this thing to omit something like this, or maybe I don't know. Yeah, so that is Schnellman. Schnellman. And I was really confused by one this thing. So I thought this is a minus. This is not a minus. This is a dash, and this is a minus. So don't get confused. So, so we are basically replacing this with this and this. So this is not a minus. Yeah, thank you for watching. If you have any doubts, please ask me in the comments below.